Hi everyone. In this video we're going to be discussing how to solve exponential and logarithmic equations. Now, in exponential equations, the reason why we know things are exponential is because you're going to notice that the x is in the exponent. Anytime the x is in the exponent, you're working with an exponential equation. Now, exponential equations can either be written as a number or a letter e, which we'll do in a couple of minutes. So the first thing is, when you're working with an exponential equation, you notice your exponent's x. Your goal is to get the same exact base. First thing you always try to do is get the same base. Now notice, okay, this is 2 to the x. I know this is 32. I'm always going to try to break down the bigger number to make it the small number. So then you have to think about, okay, is there a number that I can raise to a power of 2 to give me 32? Hopefully you said 2 to the 5th. Because 2 to the 5th is going to give you 32. Now the reason why we do this is because the second we get the same exact base, the bases are going to cancel out, and this is just going to equal to x equals 5, and that's your answer. So our goal, anytime you see an exponential equation, x in the exponent, get the same base. Then you get a problem like number 2, where you see a fraction. So when you see the fraction, you're going to ask yourself, okay, well, why isn't the other one a fraction? And if this isn't a fraction, we need to convert this to make it look like that. And this is kind of like your trick. Anytime you see a fraction, chances are what you're going to do is you're going to flip this. You're going to just make this 3. But the thing is, if you flip it, you have to make sure that you include a negative power. Because anytime that you have a negative power, you could always flip a fraction. And then I'm going to equal this to 27. And now this looks similar to this. So then I'm going to ask myself, okay, what number can I raise, or can I break 27 down? Well, I'll notice that 3 can go into 27. And you also ask yourself, well, what number? And that would be 3 to the 3rd. Now because of that, these 3's are going to cancel out, and I'm going to get negative x is equal to 3. Therefore, x has to equal to negative 3. And that's your final answer. So whenever you notice that you have a fraction, your goal is to make sure that you make this look similar to that. Okay. So then we'll get to another problem. And in this problem, you have 6x minus 2 plus 3 equals 28. Same exact thing. It's an exponential equation. How do I know x is in the exponent? So I'm going to go, well, I need to get this by itself. You always try to get the exponential equation by itself. So I'm going to subtract 3. And that's going to give me 6 to the x minus 2 is equal to 25. Then I'm going to ask myself, okay, what number can I break 25 down to make it look like 6? And there actually isn't a number that I can do that. There is no number that I can break down 25 to make it 6. So when that happens, I still need to solve for x, but you're going to add ln 6 to both sides. ln at 6x minus 2 and ln 25. Anytime you cannot break down a number, you're going to add ln to both sides. Now the reason why you do that is because in a previous lesson, you learned that anytime you have an x minus 2 and an ln, you can take this x minus 2 and bring it to the front. You could always move an exponent to the front by the power property. So once we do that, you're going to get x minus 2 parentheses ln 6 equals ln 25. And don't forget the main goal. The main goal was to solve for x. So I'll divide by ln 6. Divide by ln 6. This is going to cancel out, so that's going to leave me with x minus 2 equals to ln 25 over ln 6. You could turn this into a decimal if you wanted to, or leave it just like that. And then ask yourself, okay, how do I get rid of that x? How do I get x alone? I'm going to add 2 to both sides, add 2 to both sides, and that's going to give me ln 25 over ln 6 plus 2 is equal to x, and that's my final answer. So sometimes you're going to get stuck, and if you ever get stuck, your goal is, when you can't break it down, add ln to both sides. And the reason why we add ln to both sides is take that power to the front and then just do a little bit of algebra. Okay? So that's working with bases that are numbers. But sometimes you're going to have this type of base, where e is still a number. E is 2.71, etc. So then you can ask yourself, okay, well, the second you see x in the exponent, it's exponential. So I'm going to try to get this alone. So first thing I'm going to do is I'm going to add 6, and this is going to give me 2.5 e to the x plus 4 equals 220. Well, remember, our goal is to get e by itself. E is not by itself, so I have to get rid of this 2.5. So I'm going to divide 2.5. Divide by 2.5, and this is going to give me e x plus 4 is equal to 20 divided by 2.5, which ends up giving you 8. Now your next step is, okay, well, there's no way I can break down 8 to make it look like e. So I know automatically I'm going to add ln to both sides. And hopefully you remember anytime I add ln and e and I see that, this cancels out. So I'm going to be left with x plus 4 equals to ln 8. And then your last step is just solve for x, and your final answer is x equals to ln 8 minus 4. Please, please, please do not combine this 8 and this minus 4. This is one term subtracted by 4. And that's your final answer. So whenever you see e in an exponential equation, chances are you're going to add ln. But the only time you're going to add ln is if you're able to get this by itself. So get rid of everything that's around it. Okay, so then this is going to move us to logarithmic equations. How do I solve logs and ln's? One thing you got to remember, every property that you learn for ln is the same property for logs. So then you can ask yourself, okay, well, you also learned one rule. Anytime there's a log or ln on one side and on the right side, when there's one on both sides, you're able to cancel out. But you're not able to cancel out when there's multiple logs on one side. So whenever you see multiple logs on one side, combine them. So I'm going to combine them, and that's going to give me ln. Well, remember, what happens, how do you condense a log or ln when it's being added? Hopefully you're thinking of multiplication. You're going to multiply them when you condense them, and then equal to ln 63. Now you have what you want. You have an ln on the left, you have an ln on the right. So because of that, you're able just to cancel these out. You can only cancel out ln's or logs whenever there's one on each side, not multiple. So then I'm going to distribute this, and this is going to be x. Well, actually, I'll do that on the next step. And then on the next step, I'm going to distribute this out. This is going to be x squared plus 2x equals to 63. And this is the part where you have to do a little bit of algebra. The fact that you have two x's, bring everything to one side, because you're going to be factoring out. So this is going to be x squared plus 2x minus 63 equals to 0. Then your next step is, okay, well, just factor it out. What two numbers multiply to 63 and combine to give you 2? X plus 9, x minus 7. And then solve for, you're going to get x is equal to negative 9 and x equals to 7. Now chances are you're probably done, except you have to check these two answers, because if one of these answers give you a negative in the inside of x, it's going to turn out to be an extraneous solution, meaning it's not going to be an answer. So what I'll do is I'll take negative 9 and I'll plug it into x. ln negative 9. Because I have a negative in there, I know I can't have an answer. Anytime you have ln or log of a negative number, it is not correct. It's going to give you error, and we're not going to be able to do it. So remember, if you plug a negative number into here and you see that it's negative, it's not going to work out. So then I'm going to move on to 7. Plug in 7 here, ln 7, that's fine, it's positive. I'll do the next one, ln 7 plus 2, positive. Perfect. So I know that this is my solution, and this was an extraneous solution, meaning that it's not going to work for this answer. Okay. Now for the last one. One thing I noticed, I'm solving for logs. Okay. I see multiple logs on one side, which means I have to condense one of the sides. I notice that this is a plus sign, so that means I'm multiplying. So this is going to be log 6x times x minus 5 equals to 2. So then I go, okay, well, since I'm multiplying and I have a log equals a number, what do? Anytime you have log equals a number, you're going to do the around the world method, where you're going to circle this and go around and write it as an exponential equation. So anytime, once again, you have log equals a number, you're going to solve it by around the world and write it as an exponential equation. So 6 to the x equals to x times x minus 5. Once again, anytime log equals a number, you're going to go around the world and do 6 squared equals x minus 5. That is the only way to solve a logarithmic equation, when it equals a number. So then I'll work it out. By the way, this is not an x, this is a 2. That's my mistake. 6 squared equals x minus 5. And then I'll simplify. Well, I know this is 36, and I know this is x squared minus 5x. Then you're back in the same situation you were in the last problem. Well, how do I solve this? There's two x's. Bring this 36 to the other side, because we're going to factor. Think about two numbers that multiply to 36 that combine to give you 5, and those two numbers should be x minus 9, x plus 4 equals 0. Combine x equals to 9, x equals to negative 4, and you think they're both your answers, but they're not, because you have to take these and check them into your parentheses. plug them into x. If I take 9 into here, I get log 6, 9. That's fine, that's positive. What about here? Log 6, 9 minus 5, which is 4, that's positive. So 9 works out. What about negative 4? When I plug in negative 4, that's going to give me a negative in the inside, which does not work out. I cannot have a negative inside of a log. Okay, so once again, anytime you have log equals a number, you have to go around the world and always condense in the beginning. Okay, so let's do one last example, which is going to be log base 5 of x minus log base 5 of x plus 4 equals to negative 2. So first thing I'll notice, it's logarithmic, which means that I'm going to have to probably combine. How do I know I have multiple logs on one side? Anytime you have multiple logs on one side, you're going to combine. Well, how am I going to combine? The fact that this is a minus sign means division. So then I'm going to write log base 5 of x over x plus 4. Remember, addition means multiplication, subtraction means division. So everything that's positive goes on top, everything that's negative goes on the bottom. Equals to negative 2. Now, I condensed it. I have one log equals a number, so that should trigger around the world. So it's going to be 5 to negative 2 equals, and I'm going to write exactly what that is, x over x plus 4. Now, don't get confused here. You're on the right step. What do? How do I get rid of that negative 2? Well, the only way to get rid of that is I have to bring it down. So that's going to be 1 over 5 squared equals to x over x plus 4. Then the next step is, well, what is 5 squared? Well, hopefully you agree. 5 squared is 1 over 25 equals x over x plus 4. Then you might get stuck here, but don't get stuck. It's literally fraction equals fraction. What do you do whenever you have a fraction equals a fraction? You're going to cross multiply. So when you cross multiply, you're going to get x plus 4. Cross multiply, you're going to get equals to 25x. Simplify, minus x. 4 is equal to 24x. Divide by 24, divide by 24. X is equal to 1 over 6 after you simplify it. Then that's your solution. Well, let's make sure. Take 1/6, plug it into here, because you can't have a negative once again. That's a positive, good. 1/6 into here, 1/6 plus 4, still a positive. So this checks out, and that's your answer. So anytime you have multiple logs on one side, you have to condense them. If it's being subtracted, you're going to divide them. If you have log equals a number, go around the world. If you have log equals a log, you're going to cancel them out. Okay? So, thank you guys for watching. I hope it helped, and let me know how this video went.